Hello, my name is Crystal, and today I'm going to be presenting our research project, which is titled Rats and Reward, an analysis of the minimum change in reward detectable by rats. To start off, I want to provide some background info. The first article by Green examined smaller, sooner rewards. In this article, they used only the food pellets to train the rats to use the lever. The smaller reward consisted of 2 pellets, while the larger reward consisted of 4 pellets. They also looked at water reward, which consisted of 1 or 3 dippers. The left lever produced access to smaller, sooner rewards, and the right lever produced access to later, larger rewards. The second article by Steen explored rats' preference of quantity of food reward between 1 and 3 food pellets. Both of these experiments resulted in preference over the short, smaller rewards. However, when determining reward sizes, there was no baseline to base off. This leaves uncertainty when selecting reward sizes. Our study will add to this existing research by focusing on minimum reward differences affecting biased reward preferences and will serve as a clear, instructive tool when choosing rewards. Our results could provide support that rats will remain motivated with a small quantitative reward as opposed to a maximum amount of reward. Therefore, we propose our research question, which is, what is the minimum amount of reward change that is noticeable by rats?
So now I'd like to talk about the hypothesis and the prediction. Rats will show spontaneous alternation when their reward volumes are the same and will show a choice preference when the volumes and the reward locations are different. We predict that when the percent difference in the two reward volumes is larger, the ratio of the rat going to the larger well compared to the smaller well would be higher. As we can see on this graph, as the percent difference increases, so does the ratio of going to the larger reward over going to the smaller reward. Now onto methods. For our apparatus, we used a square maze made up of 16 plexiglass barriers as seen here to section off the maze, with 4 reward wells in the corners of the maze. Our subjects included 1 female and 1 male Long Evans rat, and rats were placed on a restricted diet of food pellets to maintain 85% of their free feeding weight.
So for our pre-training procedure, each session will be divided into 2 blocks, where each subject will first run 10 forced choice trials, then 20 free choice trials. So they'll do this twice for a maximum of 60 trials per session. For the pre-training, both reward volumes will be the same, 300 microliters, and this is to establish baseline behavior and act as a control, so we can observe how the rat will behave when there is no difference in reward. This will also allow us to make sure that the rats can run the full 60 trials within the time limit. Pre-training sessions will end after reaching 30 minutes or the subject has run 60 trials, whichever comes first. For our testing phase, each session will still be divided into blocks of 10 forced choice trials, then 20 free choice trials, except now only the first block will have the same amount of reward in each well, and the blocks afterwards will have 2 different reward volumes. Reward 1 will stay the same throughout each session, but reward 2 will decrease with each block. Testing sessions will end when a significant deviation from the baseline is observed, or reward 2, the smaller reward, drops down to 100 microliters, or 30 minutes has been reached, or the subject has run 120 trials. So here's an example of the routes that will be available to the subject. As you can see, the forced choice trials, a barrier will be up, blocking the subject from entering one side, and for the free choice trials, they have the option to enter either. Also for the free choice, once they choose a side and enter that reward zone, a barrier will come up to prevent them from going to the other side. These diagrams are specifically for the north configuration, but we randomize the configurations so that the subjects run each direction, north, south, east, or west, at least once in a set of 4 sessions. So here is an example of a session. This is our graphical user interface, and this recording was taken from a pre-training session. So right now the subject is running the forced choice trials of the first block. The orange and yellow blocks represent barriers, and the green blocks represent reward delivery corners. Orange means up, yellow means barrier is down, and we can also use this interface to manually raise or lower a specific barrier, or manually deliver reward to a specific corner. On the right side of the screen, there's a table that constantly updates as the rat keeps running trials, so we can keep track of data such as what trial number they're on, which side they chose, latency time, etc. And the timer is also running here as well. Here is our overall timeline for the entire procedure. So we started with handling the rats, so they became used to human interaction and they adjusted to the vivarium environment. We did handling for a total of 4 sessions. During this time, we also introduced them to the reward, so they would become motivated to seek it out. Then we moved on to exposure, where they were able to explore the entire maze on their own without any barriers so that they would become more comfortable and not be too scared on the maze once we started pre-training and testing. Reward was also delivered to each corner when they entered the reward zone for that specific corner, with at least 60 seconds in between each reward delivery, so they would get used to going to these corners to find the reward. Then we have pre-training, which I had explained earlier, and after the rat is able to run the full 60 trials for at least 3 consecutive sessions, they are moved on into the testing phase. Currently, we have one subject who is in the pre-training phase and one subject who has just begun the testing phase.
For the results of our current study, we gathered data to analyze the learning rate of the rats, side preference, the effect of side-on latency, and spontaneous alternation behavior. In all of the graphs, the red data points represent RA1, which is the female rat in the study, and the blue data points represent RA2, the male rat. For the statistical tests, an alpha significance level of 0.05 was used to analyze the results. First, we studied the learning rate of the rats by recording the number of trials a rat ran per session. The learning curve shows that RA1 ran more trials during her first few sessions, but RA2 had a higher overall learning rate. RA2 was more motivated to run more trials as we held more sessions during the pre-training sessions. In Figure 2, we analyze side preference by recording the number of trials where the rat chose the left reward well compared to the right reward well of the maze in each session. A paired t-test analysis shows that there is no significant difference in the preference for a specific reward well side. Figure 3 demonstrates the effect of side-on latency by measuring the time it takes the rat to reach the reward well from the center start region of the maze. Using a Moods median test, we found that for RA1, the side where the reward was located did not have a significant effect on latency. However, for RA2, side did have a significant effect on latency, where the rat ran a median time of 3.098 seconds to reach the left reward well compared to 3.399 seconds to reach the right reward well. This indicates that the rat ran a median time that was faster when the reward was on the left corner of the maze. Lastly, from previous literature, we understand a rat's tendency to spontaneously alternate reward arms in a T or Y maze configuration. So we wanted to study whether they showed the same spontaneous alternation behavior in our design. To calculate the spontaneous alternation score, we start with the value 0. Add 1 point of the decision the rat makes during the free choice trial is the same as the reward choice in the previous trial, and subtract 1 point if the rat chooses the same reward arm as the previous trial. The sum of all the points is divided by the number of free choice trials in each session to normalize the score over trial number. The table at the bottom of the slide provides an example of our spontaneous alternation scoring system. Scores for data collected only counted in the results if the session had at least 14 trials. Using the bootstrap simulation method, we found that 13 sessions had a significant alternation score. So for the majority of the sessions, both rats showed a tendency to alternate between the two reward arms.
Now I'd like to discuss a bit more about our results, as well as our plans for future experimentation. So just to reiterate a bit about what Jennifer said earlier in results, as we can see in Figure 1, RA2 had a higher overall learning rate than RA1, although RA1 did show initial higher learning rates than RA2 did. In addition, here in Figure 2, we can see that there was no significant difference for side preference, which indicates that the rats did not demonstrate any bias towards either side. In Figure 3, we can see that RA1 showed no significant effect of side-on latency, while RA2 showed a significant effect of side-on latency, specifically preferring the left side. And lastly, here in Figure 4, RA1 and RA2 both showed spontaneous alternation for the majority of the sessions. Now here, we plan to continue our experimentation by slowly decreasing the difference in reward in order to determine the just noticeable difference that the rats can detect. And we would like to see if that just noticeable difference that we do find follows Weber's law. And lastly, we hope that the results of our study will aid future researchers in deciding the minimum reward differences that can create positive contrast or biased reward preferences. And lastly, these are our references. And yeah, thank you so much for watching.